Right. Hi guys. I hope you can see me. I'm just checking, just making sure that we are live. So just let me know if you're getting the feed and everything else is okay. Just give me a signal. Let me know and we can begin. Right. I just asked my wife to just check and let me know if we are coming out live. And we can begin. Okay, so I trust that you guys had a very good week. I had a very busy day, but it was very fulfilling. I had an after hours change at work and everything went as expected. You know, I always love it when changes go according to plan without any hiccups. And I am looking forward to today's live stream where we're going to be looking at IP addressing. If you can hear me, just let me know in the comments section. Just give me a thumbs up. Just let me know that you can hear me, and we can basically comments. All right, just checking. I'm just making sure that all is good. Just making sure that all is good. All right, so we will start off our live stream for today. Just two things that I need to mention before we start. Two things that I need to mention before we start. Number one, we have partnered with Exams Digest, who have donated exam vouchers to their exam practice website. And in this week's live stream, we're going to be giving away two vouchers. We're going to be giving away two vouchers. All you just need to do is to leave a comment in the comments section, and we'll do a random draw and we'll give away the vouchers. If you look in the description below, you'll be able to see information on when the deadline would be. Just leave a comment in the comment section. It will just make it easier for us to be able to reach out to you to let you know if you have won. In the event that you don't manage to win this week, in the next few weeks, we're going to be giving out two Exams Digest vouchers per live stream. If you want to purchase their exam practice, go to examsdigest.com. If you use our code networkhustle30, you get an additional 30% discount. So you get an additional 30% discount. They're not sponsoring this video, but we reached out to them and we partnered, and they have donated vouchers to give away in our live stream session. So head away to Exams Digest. They offer certification practice exam questions. You've got CompTIA, CCNA, AWS, Google, Microsoft. So any certification you're basically thinking of, they do have practice exam questions. They've got a number of free questions that you can be able to take to assess their platform and see if it basically works for you. Okay, so that's out of the way. So that's number one. And the second one, I'm just still working on the structure of the live stream and how best we're going to go about it. The first section will basically cover questions that were probably raised in the last live stream, so that at least I can answer those questions, and then we can get into our topic for the day. So if you are in a rush, please just look at the description. You'll be able to see the promotion for Exams Digest. So let's begin. Last week, I got a question from one of the viewers, and his name is Rootkit, and he was asking about pursuing a master's in networking. He's based in Portugal, and he was asking, will it be better to go for certification or pursue a master's in networking? Now, I had the time to look at the curricula of most universities in Portugal, and the challenge that I came across is that the content that is covered in the degree programs is more theoretical. So if you can see on the screen, my recommendation is universities in the UK. And the reason why I recommend universities in the UK is because they offer an academic qualification that also is comprised of certification and practical skills. So when you graduate, you're going to graduate with a degree, but at the same time, you're going to graduate with a professional qualification that is going to make you marketable when you go out in the market looking for a job. So I'm just going to show two universities. That's number one is Sheffield Hallam University. And this is their master's in advanced computer networks. And these are the things that I look for when I'm looking at the curricula for a master's program. So number one, you're going to learn skills to design, implement, and troubleshoot enterprise networks. You'll tackle Cisco certifications whilst developing your career. So within the actual exam program, you'll be going through Cisco certifications as part and parcel. And if you look at the curricula, you're basically covering CCNP within the actual master's degree program. So for those that want to pursue a master's in networking, my recommendation or advice is try and find an institution that gives you some form of certification practical course embedded in the master's program. This has become a standard mainly in first world countries. So if you look at universities in the UK, in the US, Australia, they tend to integrate your certifications within the master's program. So for those that are considering to do a master's in IT, that is what I would recommend for you to be able to go and pursue. So let's go to our topic for the day. We're looking at IP addressing. But I want us to start from a position of what we know and what is the problem. One of the key elements of learning is understanding why. If you understand why, it becomes easier for you to learn. Just let me know if you can see the slide presentation that is on the screen. Just give me a thumbs up if you can see the slide presentation, because that is going to be where our topic of the day is going to be anchored on. Right. So if you understand your why, it becomes easier to solve your problem. So in our slide, the first problem that we have was one that banks faced in the United States. So in the 1800s, when the banking sector was basically growing in the US, people were sending money, and it started becoming a bit of a challenge to send money to different banks, right? Because banks were growing in number. So you had multiple banks in the country, and transferring money from one bank to another started becoming a challenge. Why? Because they did not have a system that could easily identify one bank from the other. So they came up with what is known as a branch code in an effort to solve that problem. So what that branch code basically did is, if you're sending money to bank A, their account number would start with a particular identifier that separates them from bank number B. Now, in Australia, we have what we call BSB, which is bank, state, and branch. So if you want to send money to someone who is in Australia, you are going to need the BSB number, which is a 6-digit number. So my bank's BSB is 066-000. So on that BSB, and then you got the account number, which is made out of 8 digits. So I'll just put XXX and Y, and Y. Right, so that's our 8-digit account number. So the first 2 digits of the BSB, which is 06, signifies the bank. Right, so that is the bank identifier, and my bank is Commonwealth. I love that bank. I'm not being sponsored. They're not sponsoring this video, but that's the bank that I basically bank with. So 06 will signify the bank, and this third digit signifies the state, which in this case it is 6, which stands for WA, which is Western Australia, where Perth is located. And then 000 would be the branch. So that was branch number 000 in WA, and the bank belongs to Commonwealth. So if you send me money, this is the code that the banks use to determine where my money is going to be routed to. Right. So if the BSB starts with 06, is going to be sent to Commonwealth as a bank. And if the state code is 6, it's going to be sent to Western Australia. And if the branch is 000, it's going to be sent to St. George Terrace, which is where my branch resides. And then only when you get to St. George Terrace as a branch, can you then use my account number and find my account in that particular system. So all these 4 pictures in our slide are basically, they have one thing in common, which is addressing, right? We need addresses for everything that we do in our day-to-day life. Most of us have probably purchased things online. For Amazon to send you your package, they need to know your home address. Without your home address, the package can't make it to you. Now, my address is 12 Duan Road. I hope you guys won't come and throw stones at my house because you probably don't like the nature of the presentation. But anyway, so my address is 12 Duan Road, and the suburb is called Rosebery. And the postcode is 0832, and the state is NT. Right. I hope my handwriting is coming out clear and you can be able to see. But just work with me, because us understanding how addressing works on the things that we deal with on a day-to-day basis is going to make the IP addressing section much more easier to understand. So if you were to send me a package from the UK, when that package comes from the UK, initially its destination is going to be Australia, right? Because it's going to Australia as a country. But when it arrives in Australia, it needs to catch the plane that is going to NT, which is Northern Territory. That's my state. When it gets to NT, it gets put into a truck that is going towards 0832, which is my postcode. And then from 0832, which is my postcode, the post office then puts it in a car that is going towards Rosebery. And then Rosebery post office then sends it by motorbike to a street called Duan Road. And from that street, you are able to then find my house on number 12. So addressing allows the sender and the receiver to be able to communicate. I think most of us have traded in Bitcoin, or Bitcoin is probably doing very well on the market at the moment. Same concept. If I want to send you money, I need your Bitcoin address. And it is that address that is going to locate you amongst other Bitcoin users so that you can get the money that I've sent you. Now, we can agree that if I get the Bitcoin address incorrectly, then there's a very high chance that the money might not make it to you. So I need to make sure that the address is correct. We face the same predicament in the networking or IT world. We need a way of being able to identify computers on the network so that I am able to send packets from this location to PCA that is located on my network. And the only way that I can identify that PC on the network, we use what is known as an IP address. So an IP address is basically an address that identifies a device on an IP network. And it looks something like this: 192.168.1.1. So that would be the nature or what the IP address basically looks like. And in that IP address, it is made up of two components. We have the network ID and we have the host ID. The network ID basically identifies the network that the device belongs to. And so a typical example is the network ID is like my street name, right? Duan Road. I'm not the only one who stays in the street. I have neighbors, but we all stay on the same street. So the network ID identifies the network part of the IP address, and then the host ID identifies the individual device on that particular network. So a PC that is 192.168.1.1 and 192.168.1.2 basically belong to the same network, right? So now that we understand what problem addressing was trying to solve, we're going to look at the definition of an IP address. So in simple terms, an IP address is a unique address that identifies a device on the internet or on the local network. So for those that are not aware, any device that needs to communicate on an internet protocol network, which is IP network, requires an IP address. Whether the device is local, meaning in your home network, or the device is public, meaning it's on the internet, they all need IP addresses. So your google.com has an IP address, Netflix has an IP address. This is how they communicate on the internet. So let's look at the structure of the IP address. For those that are just joined us, I just want to just let you know that we have partnered with Exams Digest, who have donated access to the exam practice software, exam practice website. So just check the description below. You can have a look at what is required. Just leave a comment in the comment section and we will select people randomly to win 2 vouchers for this live stream. So just wanted to let you know just in case. Right, so continuing with our IP address, the structure of an IP address. This is the typical IP address, 192.168.10.1. IP addresses are written in what is known as a dotted decimal notation, right? Dotted decimal notation. And what that basically means is we separate the IP address with dots in between. So this is dot number 1, this is number 2, and this is number 3. So these are the markers that separate our IP address. So we write our IP address in dotted decimal. We can also write our IP address in what is known as binary, which is what I have put below. So this is our IP address in binary. Computers talk in ones and zeros. They don't speak English like what we do. They talk in ones and zeros. So when you convert this 192 value, it ends up as this particular binary address. And we're going to cover that in today's video. We're going to go through the whole conversion of IP address to binary. Now, an IP address is made out of 32 bits. If you count the bits that are on the binary address from here to here, it adds up to 32 bits. And a bit is basically a 1 or a 0, right? So a bit is a state that, it's a state that you can have. It's either 1 or 0. So it's made out of 32 bits. And the bits are broken down into what are known as octets, right? So an octet is 8 bits. So if you count 1, 2, 3, 4, 5, 6, 7, 8. That makes up one octet, right? So this makes up octet 1. And then this will make up octet number 2. And this will make up octet number 3. And that will make up octet number 4. Right, so an IP address is made out of 32 bits, 4 octets. Each octet is 1 byte, and a byte is 8 bits. Right, so an octet and a byte are basically one and the same thing. Each octet is 8 bits, and a byte, each octet is 8 bits, and a byte is 8 bits. So we have looked at the structure of our IP address. Now, we're going to look at simple math. I know most of us, math is not one of our favorite subjects, but we're just going to do, basic simple maths. And I just want you to work with me. I want you to imagine I give you 8 coins, right? And these 8 coins have different values. And as you can see on the screen, the first coin is worth $1. The second coin is $2. The third coin is $4. The fourth is 8, 16, 32, 64, and 128. Right, so I give you 8 coins, and this is the value of the 8 coins. And I ask you to go and pay your bills. Now, we're doing simple addition. If your rent is $192, right? I want you to pick how many coins you need to get to 192. Right, so your rent is $192. I give you these coins from $128 coin, $64 coin, $32 coin, and I ask you to go and pay rent. How many of these coins are you going to need in order for you to pay rent? And for the coin that you're going to require, you need to put a 1 underneath. And for the coins that you don't need, you put a 0. Right, so that's how it basically goes. For the coins that you need, you put a 1. For the coins that you don't need, you put a 0. So let's go through. Our rent is 192. So for me to get to 192, do I need 128? Probably yes, because if I add 1, 2, 4, 8, 16, 32, 64, without 128, I'm not going to make it to 192. So I'm going to need 128. So I put a 1 underneath 128. So 128 plus 64 gives me 192. So I put a 1. So 128 plus 64 gives me 192. So I already arrived at my 192. So I no longer need all these coins. So I'm going to put 0 for 32, 0 for 16, 0 for 8, 0 for 4, 0 for 2, and 0 for 1. That's pretty basic. If you got any questions, just let me know. If you're not getting it, you're not understanding, just tell me. I'll try and go back. Okay. So we've paid our rent with 2 coins, $128 coin, $164 coin. Okay, let's look at power. Right, our power is $168. Do we need 128? Yes. 128 plus 64 is 192, which is more than 168. So we're going to put a 0 here because we don't need a $64 coin. And then 128 plus 32 gives us 160. Right, so we're going to put a 1 here because we need the 32. 160 plus 16 is going to give us 176, which is more than what we need. So we're going to put a 0. 160 plus 8 is going to give us 168. So we're going to put a 1, and you're going to put a 0, and a 0, and a 0. Right, water, man, this water is very cheap. I don't know which country this is that is water that's this cheap, but our water bill is $10. So 128, we can't use the $128 coin because it's too much. So we're going to put 0. $64, it's too much. We're going to put 0. $32, 0. because we don't need a $32 coin. Same with 16. 8, we need one $8 coin. If we put a $4 coin, that's going to be $12, so it's going to be more than. So we put 0. And then we need a $2 coin. We're going to put 1. 8 plus 2 is 10. And then you're going to put a 0. And finally, our last bill that we're paying is internet. And our internet bill is $72. So 128 is too much, so we're going to put a 0. 64, yes, we're going to need 64. We're going to put a 1. 32 is too much. 16 is too much. 64 plus 8 gives us 72. So we're going to put a 1 and then 0, 0, 0. So what we've just basically done is we have converted this IP address 192.168.10.72 into binary. So if you think about it in monetary terms, it becomes simpler and easier to be able to understand. So if I were to then write it down, our binary address would be 100.100.100.010 dot. I don't know why my pen is acting up, so my writing is probably not as clear as I'd want it to be. And then 010.010.000. Right, so that would be our IP address of the representation of 192.168.10.72. Is there anyone who's got any questions, who is saying, Tanae, I think I'm a bit lost? You might want to come again. Please just let me know in the comment section. If you've got any questions, just let me know. Tell me what is it that you might not be understanding, that you would basically would want me to look at. Okay, no questions. So this is how you convert your IP address from the dotted decimal notation into binary. So now we're going to look at doing the, or maybe let me not, before we do, okay, let's see, just something happened on my screen. Let me just try and revert that back. Control Z. Okay, I just want to let's look at another example that we can convert to be able to reinforce this particular subject, because this is the key of IP addressing, the ability of being able to convert your IP address from dotted decimal notation into binary. So let's look at an IP address 10.181.54.32. Same process. We're trying to get 10 here, we're trying to get 181 here, we're trying to get 54 here, and we're trying to get 32 here. So for us to get 10, let's start from the right going to the left. Do we need 1? No. Do we need 2? Yes. Do we need 4? No. Do we need 8? Yes, we put a 1 and then 0, 0, 0, 0. 181, we're going to need 128. 128 plus 64, that's 192, which is too much. So we're going to put a 0. 128 plus 32 gives us 160. We put a 1. 160 plus 16 gives us 176. We put a 1 because we're trying to get to 181. 176 plus 8 gives us 184, which is more than what we need. So we're going to put a 0. And then 176 plus 4 is going to give us 180. You put a 1 and you put a 0 and then you put a 1. For 54, we're going to 0, 0, 32, yes. 16 plus 32 gives us 48. That's 48 plus 8 is 56, which is more than 48 plus 4, 52. 52 plus 2, 54, 0. And then for our internet, that's $32. So that's going to be 0, 0, 1, 0, 0, 0, 0, 0. So what is important for you to understand is to master this part. Right. Let me probably highlight it in a different color so that I can reinforce. Right. So you need to understand how these values increase. These are what is known as binary, of which I'm probably going to cover in the next 2 slides. We're going to look at how binary works and how that basically increases. Okay, so let's now do the reverse. So we have gone forward. Now we want to do the reverse part. And just this. Okay, cool. We just want to do the reverse. So the reverse is I give you the binary value, and now I want to get the dotted decimal notation. I give you the binary value. I need the dotted decimal notation. So we've got our IP address, which is 10101100. So we take 128. What's 128 plus 32? It's 160. 160 plus 8, 168. 168 plus 4, which is 172. So our rent is 172. And then what is the cost of our power? Our power is 000. We only have 1 on 16. So our power is $16. And then our water is 8 plus 2. So we're only adding wherever you find a 1. 8 plus 2. And 8 plus 2 gives us 10. And the last one is our internet bill is 128. 128 plus 2 gives us 130. 130 plus 1, that's 131. So our IP address is 172.16.10.131. So I hope this is basically giving clarity as to how do we convert an IP address into binary and how do we convert a binary address into a dotted decimal IP address. So we are working with this once again. This is the most important part because we are dealing with binary in terms of the powers of 2. So if you want to understand IP addressing and you want to understand subnetting and how you break down networks and how you deal with subnet masks, how you deal with the hosts on a network, it is important for you to understand that when we are dealing with binary math, we're dealing with the powers of 2. Right. So 2 to the power 0, I'm sure most of us did that in maths, probably in primary school. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3. So 2 to the power 3 is basically 2 times 2 times 2, which is equals to 8. I don't know why my pen is acting up. And 2 to the power 4 would be 2 times 2 times 2 times 2, which is equals to 16. So what you want to identify is a pattern, right? Wherever you go from the right to the left, the number is doubling itself, right? So 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, 16 becomes 32. So all you need to understand is just the first power, and the rest is you're multiplying the number by 2 to be able to get. So 32 becomes 64, 64 becomes 128, 128 times 2 is 256. 256 is 512. 512 is 1024. 1024, 2048. So this becomes 2 to the power 8, 2 to the power 9, 2 to the power 10, 2 to the power 11, 2 to the power 12, and 2 to the power 13, which is 8192. 16,384. That's 2 to the power 14 and 2 to the power 16. You need to practice increasing your numbers in the powers of 2, because the whole premise of subnetting is based in your ability to be able to raise, to be able to define your subnets to the values that your binary value is basically increasing. So that is basically what we were covering today. So if you look back, we covered addresses, why we need addresses, just addresses in generally. And addresses basically solve a problem of sender and receiver. If I want to send you something, I need an address that I can locate you, whether it is your home address, whether it is your bank account. And we went ahead to look at the fact that the bank account or home address is segmented into different segments in order to make routing much more simpler. In the bank account, we spoke about the BSB, which is what separates banks, states, and branches for Australian banks. For your home address, we spoke about your postcode and your street address, which separates your house from the next house. We went to then look at Bitcoin, which basically has the same addressing mechanism. And we came back to our focal point for today, which was IP addressing. And we said that in the IT or networking arena or industry, we use IP addressing to be able to locate devices on the network. So we looked at the structure of an IP address, and we said the IP address is a 32-bit address that is made out of